Thanks, Carrie. So building on the discussion we started earlier today on integrated distribution planning, here we're going to zoom in on one of the dimensions we discussed on resilience planning. Next slide, please. So as I was illustrating earlier, there are really three sort of domains of planning analysis that happen. The one we're going to focus on here is on reliability and resilience. Next slide, please. So one of the things as we think about resilience and planning for resilience is really thinking, pretty broadly about the role that electricity plays in our modern society, not only individual customers, but also those critical facilities and essential facilities within a community as well. So this interrelationship to other critical infrastructures or essential services like banking or gas stations or the like, as may be identified within your state, within the communities within your state. It's important to understand that context and the relationship to the electric grid and the dependencies, the requirements that those infrastructures have with respect to electricity. That is, do they have backup solutions or not? What are the requirements that they have for both experiencing no outages to, if there is an outage, what's the implication for their ability to get back up and running? And what's the impact then on that community? So this understanding of the interdependencies is an important consideration going into any resiliency analysis. And this touches on part of the reason I mentioned earlier about the need to engage with local communities, because this is where this information really starts to emerge, in addition to what may come out of the state energy, state emergency services efforts will also be another source of good information to feed into this process. Next slide, please. So as I described,
I think we have a poll. Do we have a poll for?
Oh yeah, thank you.
It's off. Yep. Launching it.
So the quick poll, what is the level of maturity of threat and risk-based assessments for distribution resilience planning in your state? And again, this kind of builds. So the first level is kind of focused on asset hardening and vegetation management and reliability assessments. What are the classic kinds of things that utilities may have done? The second is to more systematically build on that and add environmental and cyber threat assessments. So environmental meaning, storm severity and the like, and the impacts of those, as well as increasing potential for cyber threats. Additionally, that starting to look at something around applying those things into a threat risk-based mitigation analysis, for example, a bow tie type analysis. And then sort of fourth is those things plus starting to apply some form of a risk spend efficiency analysis to prioritize investments to be able to address the overall objectives. Or you're not clear on what utilities are doing right now. Okay, interesting. Okay, so what we're going to do is cover each of these dimensions a bit, and certainly we can explore further in the Q&A. So if we could go to slide 5. Oh, sorry, slide 4, thank you. I forgot where we were. Thanks, Gary. So as we had talked about earlier, coming back to this flow diagram of integrated distribution planning, what we're going to talk about over the next few slides is really zeroing in on a couple of dimensions related to the planning objectives and criteria, and then the resilience and reliability analysis that I've highlighted here in the red boxes, We'll also talk about how that then informs and we think about developing longer-term plans in terms of prioritization and identifying solutions. So we'll cover a number of these dimensions, but the next couple slides are going to zero in on these first couple. Next slide, please. So one of the things that in any sort of planning and then how it relates to implementation and then ultimately operations is there is this overall life cycle where we start with planning and objectives or objectives and criteria, the integrated planning process, identifying solutions, solution prioritization. You know, the diagram that was shown on the prior slide really is a decomposition of these four dimensions that are represented here. But as we think about resiliency and reliability planning, it's important to understand the operational stage and then how this ties to a post-event evaluation and then the link back, the feedback loop back into the objectives and criteria. So there's this sort of life cycle, if you will, of how this planning fits into the overall life cycle, as I mentioned. One of the things is important to understand is there's a lot of definitions and discussion in the industry around definition of resilience versus reliability. For the purpose of this discussion today, we're going to talk about resilience in the context of an engineering context, that is an architectural context, which is the grid's ability to withstand an impact of cyber and physical threats. So the ability to not fail, to not have an outage is what we're referring to in terms of resilience. Sometimes it's talked about, I've heard some vendors talk about resilience in terms of recovery in the operations mode, but that isn't really correct from an engineering or architectural standpoint. It's really about withstanding the threat in the first place. So in this context, we're going to use it in this definition. So the next slide, please. So when we think about what it is we need to be resilient against, what are we going to need to be able to withstand? We need to be able to assess those potential threats, those things that might otherwise break the electric grid, if you will, or cause failures on different components of the grid, a circuit breaker, transformer, pole, wire, etc. What are those things? This is an example coming out of Hawaii that was done by Hawaiian Electric as part of a broader engagement with local community and state emergency services and other folks to look at, and obviously the commission, to look at and assess what are the various threats that they may see on their system and start to understand in terms of priority in relation to the potential impact on the electric system and by extension then customer impact, critical facilities, societal impact. And so this idea of going through and identifying those potential threats, and you can see that cyber attack is one of those. It may be a little difficult, but it's the fourth one down. So you've got hurricane, tsunami, flooding, cyber attack, and so on. Each area obviously is going to have its own unique set of issues. Hawaii doesn't deal with ice storms, and obviously in the upper mid-continent, it's a particular challenge. And so each area has its own unique set of threats, and you would want to do a prioritization of those so you can start to then understand the impacts. The next slide, please. Now, as part of that process, you're also trying to understand that each type of event is going to have its own level of intensity with respect to the impact on this electric grid and therefore customers, critical facilities, vulnerable communities, and the like. And so there's a different scale related to different events. You can have what we call a reliability event, which is a very short duration outage, let's say a car pole accident. Somebody runs into a telephone pole and knocks it over and there's an outage, or a squirrel gets into a distribution across a distribution insulator and causes the line to trip, and then you have a very localized outage for a relatively few number of customers in short duration. We call those reliability events. and typically account for those in our metrics as a reliability event, the Sadie-Katie kind of metrics. Those things that are considered major events are what I'm trying to represent here in the blue shaded boxes. And those start to have different dimensions. Those start to be either a major event, but at a local scale, meaning that it's in a fairly confined area, say within a county, and the number of customers and so on, and the impact is more localized. We can have something I would consider a major local event that starts to cut across multiple counties, let's say, and starts to have a much larger impact. Certainly, some of the major storms that we've seen have had, certainly started out at the major local event, and a major regional event is where we start to cross, state lines, and now we have, let's say, a weather event that basically cuts across multiple state lines, and so you have a larger regional impact that may be involved. The reason for thinking about this is twofold. One is, what's the scale at which you need to think about the level of resilience? The other is, what's the level of coordination that would be needed to be able to think about planning for that kind of event, and certainly in terms of responding to such an event. That also comes into play here. But it's really important to understand how to think about these and really unpack the threats as they may be, have different scales, and understand what that means in terms of potential grid failures. Next slide, please. So one of the methods that is kind of a best practice in a number of industry sectors, by the way, but is being applied in the electric industry, is something called a bow tie assessment or bow tie analysis. And this is a way to think about what are the potential threats that have gone through the prior analysis, and understanding both the nature of that, either weather-related or natural disaster, say an earthquake or the like type event, and or a cyber threat, and understanding those threats, the potential impact to the system, and which is the second step on the left, identifying physical and cyber vulnerabilities. That's the potential impact. Then identifying what are those potential solutions that might prevent that specific failure. So hardening, so when we think about distribution hardening, that's an attempt to basically prevent a specific failure. In that case, maybe wires going down or the like, or poles snapping. So there are specific solutions identified to that vulnerability. That vulnerability is the specific failure that you're trying to avoid, which is in the middle of this bow tie diagram. So whether it's a substation transformer or a transformer out on a distribution line or a pole or a conductor, any of those things would be these specific failures. Now, in every case, we're not always able to avoid having that particular failure. And so what you want to have is plan B. That is, what happens if that failure still occurs? Do you have a mitigation in place to basically reduce the impact, both on the physical grid as well as customer impact in terms of outages? So the potential impacts are that next step. If your first option, that is to try and prevent the failure, is, so what are those potential mitigations? You try to or the need, and then, what are those potential mitigations, solutions? And then what is the resulting net impact that may occur if there was a failure, and you use your mitigations, because typically you're not able to mitigate every potential failure that may occur. So what's the result, and is there acceptable risk tolerance related to that, and as well the cost associated both with the plan A, that is to prevent the failure, and plan B to mitigate that potential failure. So it's really important to kind of think about this in this sort of plan A, plan B type analysis to think about it. Now, one of the things that occurs, as you can imagine, is that a number of these different threats, and environmental threats in particular, have some overlapping sort of impacts on the distribution system. So, they're not necessarily going to uniquely impact the distribution system differently in terms of the kind of failures that may be created and the kinds of solutions that may be employed may be able to mitigate multiple types of threats. So part of this analysis is also synthesizing those potential impacts to understand how a potential solution may be able to address multiple threats. Next slide, please. So as we talked about earlier, most of the capital investments in the distribution system have something directly tied to enabling greater resilience and reliability, or, as I'm showing here with information technology and customer service requests, have a, they're not so directly, but there's still aspects of that, what's done there that can address reliability and resilience if thought about as part of the process. So it's very important that we really understand what it is we're trying to accomplish with resilience and reliability, because a lot of money that's being spent in the distribution system has this potential for making things better. And so being able to make sure as part of the planning process that we have line of sight to how that's being thought about, not only just in grid modernization or in those categories called resiliency and reliability, but also when we think about aging infrastructure replacement. So in aging infrastructure replacement, are we, when we're replacing that infrastructure, are we taking into account what is a better design practice for hardening or for how we configure the system, such that what goes in isn't exactly what came out in terms of design, but rather is an enhanced version that takes into account reliability and resilience. The emergency repairs is actually storm damage repair. And so, the last thing we want to do is put exactly out what was, failed, just so that it can fail again at some future date, but rather, what you use for the emergency repairs is the improved kind of approach or improved equipment, such that you take advantage of that opportunity that presents itself when you have to replace that damaged equipment by putting the newer design-based equipment out. What this means, by the way, in practice is that the design standards and the related equipment associated with that design standard that's more resilient is sitting in inventory, so that when crews go to get the equipment to go make the storm repairs, they're bringing their new design-based equipment, not the old types of equipment that were used under the prior less resilient designs. So it means that there's more effort on the front end that needs to be done so these things can actually happen in practice. There are additional benefits by thinking about this resilience that then accrue to other aspects of that Venn diagram I talked about at the outset for planning, which has to do with things like DER and microgrid integration, how we think about other needs that we have as we move more into electrified societies, particularly with electric vehicles and the like. And so there's overlays and interrelationships there as well that should be taken into account. Next slide, please. So as I touched on earlier, it's really important to understand that there is this Maslow's hierarchy of investments, really starting with the base infrastructure. So what are we looking at with the fundamental poles and wires and that infrastructure, the conductor, whether it's underground or overhead? What's our basic capability? What does that look like in terms of its condition, its current status and capabilities? And then how do we think about the overlay of more intelligence on top of that to achieve the outcomes that we're looking at? As I touched on the prior slide in the text but didn't speak to it, one of the things that's increasingly important is having visibility into the state of the grid. Certainly as in those places that have adopted smart metering have realized that understanding whether customers are, have power out and additional sensors on the distribution to be able to understand where faults are detected really help understand the response time in terms of restoration, but also as we think forward in the planning through the evaluation how we might think about hardening in particular areas to be able to, or other dimensions that we may do to mitigate the impacts of various resilience threats to ensure power continues to be available for customers in critical facilities. Which leads to then thinking about what are some of the options we might think about to structurally to enhance the resilience of the grid, and that's where microgrids really fit in as an option to the fundamental architecture or structure of the grid. It's another dimension of how we might ensure continued operation of the system, particularly when we have an event. So it's another tool in the toolbox to think about as we look at this overall stack. But it's important to recognize that microgrids, to really work effectively, need to have these other dimensions as well. You can't just have a microgrid and the rest of this not to work to really make these things effective. And part of the reason is that microgrids, by design generally, are not operating in island mode, but a very few hours out of any particular year. 99.99% of the time, microgrids are interconnected to the grid, and in many cases, those microgrids have resources that are participating in wholesale markets or providing services to the grid or the like, and the economics are really dependent on that, which means that you need to have an ability to have that interconnection, robust interconnection. So there's a balance there in terms of thinking about the relationship about how microgrids can play in the broader grid as a whole. That's an important consideration. Next slide, please. So one of the things that, building on that, is that we started to discuss as part of some of the activities with the Department of Energy is around thinking about how to consider the role that grid investments and microgrid, or what we'll call, even backup generation, what are calling point solutions. So community-based solutions versus point solutions being for a specific customer or a specific facility, for community meaning multiple customers, multiple, maybe a whole community. So how do we think about the balance of that to achieve our overall objective? Develop this 2x2 as a way to start to conceptually think about the relationship on the resilience solution scope side, those point solutions and those community-based solutions. And not to say these are either or. The point is there's a portfolio of these that are needed. The societal benefit, where is the benefit that that accrues to these various solutions? Is it an individual customer that may have their backup battery or backup generation? Is it a single critical facility, but that facility serves a community? And so therefore there's a greater societal benefit. Is it a set of solutions that address all critical facilities or all critical facilities and essential services, which gets to a certain level of societal benefit? And then community-based can address those critical facilities and essential facilities, but also a wider range of residential and business communities, say an industrial park or residential community, and then entire neighborhoods, town, or all customers in a particular area, say a county or the like. So this can scale as we think about this, but one of the things that we haven't really been, in a number of places yet that I'm aware of, really been looking holistically in the planning process about what's happening on the customer side, and how do we take that into account when we think about resilience set of solutions and portfolio. Now, this isn't to say that these customer actions need to be part of some non-wires alternative. I'm not saying that at all, because customers are doing these, and many of us, I'm sure in this conversation today, have already been taking their own individual actions. I certainly have, with what I've been going through here in California. So it's really a question of how do we think about what the need is and understanding what the current state is with respect to what solutions that individual customers or communities have taken, and what is the role that the grid needs to do to both enable that, as well as be able to understand its role in terms of enabling a broader resilient infrastructure. So this is a challenge. I don't know that there's an immediate answer. I know there's some colleagues at some of the national labs that are working on some of these opportunities. Uh, uh, Bobby Jeffers at Sandia in particular has been working with a number of communities to try and work through some of these portfolio analysis. But this is an area, I think, as we start to look at the distribution planning process, is something that would be a useful exercise to discuss, maybe initially through technical conferences that you may conduct to really sort of explore how this is being considered as part of the overall resilience solution portfolio, if you will. Next slide, please. The other thing, when we start to talk about roles and responsibilities, given the nature of these different events, means that as we go from a very localized event to sort of some what I call the major local or major regional, we're going to end up with more people involved, more organizations having an interest in helping to define what the objectives are. So this is really important to understand who will need to be necessarily involved in both post-event evaluation, but much more so on the upfront planning process and determining objectives and planning criteria. So I think the next slide starts to explore a little further. So the next slide, please. This is something that we consider this sort of draft, but this is something we started to sketch out much earlier this year in terms of a starting point for thinking about the various roles that folks may play within the state. Obviously, there, as we noted on the other slide, a federal dimension when we start to get into multi-state impacts or other, federal interests that, for example, the Department of Defense and the like in a particular state or community. But for simplicity and what can fit on the slide, we've got sort of a state perspective here. And I won't go through the details here, but the point is there are a number of dimensions that could be quite helpful to think about how to link activities across these different interests and sort of focus, if you will, in terms of these needs around resilience, and how do we engage stakeholders effectively in this process across these different areas of focus. From at the broader state level, as well as at the commission's focus across that state, and then individual utilities and communities and the like. The next slide, please. So to kind of close, there's several questions that could be that you may want to consider thinking about. And again, in the context here of distribution grid investments affecting the system's physical and cyber security, it's an important starting point. So how are potential threats being assessed and translated into planning considerations? That's a pretty important aspect. Is it something like what Hawaii is doing, or is it something else? Is the state leading that? Is the utility doing it? Is that something the commission yourselves are facilitating? Is there a clear, logical explanation how proposed investment directly or indirectly supports resiliency? There ought to be a pretty clear line of sight and logical, discussion about how that fits, and that really gets to the third as well. So, as proposals are coming forward, both in terms of distribution plans, longer-term plans, but also in various rate cases or applications for funding, there ought to be pretty clear about how those particular investments link to the overall resiliency objectives. And to the extent that they're using some type of analysis like the bow tie I mentioned, they ought to be able to tie to whether this is investment is about preventing an outage or whether it's about mitigating the effects if there's a failure after the fact and being able to reconcile that. And then, as we talked about, how do we think about thinking about what's happening on the customer side or independent microgrid solution type solutions? How does that fit within achieving the overall resilience objective of that community, of that state? And do we have all the key stakeholders involved in an effective engagement process, including the local communities? So with that, I think I'm done, and I don't know if there's a little time for Q&A.
Terrific. Thanks. And I will also mention that I will also drop the link for um, Neighbor has a section on resilience on our website too, so I will just drop that in. So the first question that we have the um, from the audience is, how can public utility commissions decide on appropriate levels of investments and resilience of distributed systems? For example, how can commissions determine whether um, proposed large utility investments is worthwhile and not just an expansion of a rate base?
So I think I would say twofold. It kind of builds on what I was mentioning just on the prior slide. So the first is having a clear understanding of what the objectives and by extension the planning criteria that have been identified for the state and in particular for that particular utility. And it may extend even to that utility in relation to particular communities or subsets of communities. And by understanding that, then you can start to tie those investments to that particular need. Through that analysis, there ought to be able to be consideration as to whether utility investment or the fact that customers may be or some independent development is addressing that need, and therefore the utility doesn't necessarily have to also build something, is something that can be considered as part of the evaluation of the planning and something that the utility ought to be able to describe in terms of how they've approached it. It's possible that you would still make a great investment and the utility and the customer does something on their side as a redundant, which is that sort of plan B, if you will. And so being able to understand that and be able to reconcile that's important. Now, how do you think about accomplishing that, recognizing that there's never enough budget to do everything you possibly would want to do? That's where we need to have some prioritization methods. And the one that I think works best is one that that I think it has been used in California, which is around this risk spend efficiency model. So the risk being identified in terms of a number of different parameters. They use something called a multi-attribute value framework. So basically, they look at customer interruption, so customer outage duration potential. They look at things like financial impact to customers, to even the utility loss revenue, but it's largely driven by customer or could be including society, but that starts to get really tricky. And then you have some other there's some other dimensions in there as well. Well, obviously they've got a wildfire risk that has a pretty big potential impact. So you could look at, you can set up whatever is the appropriate attributes for your jurisdiction, and then from that, that sets up the risk side of it. So you get a risk score, a normalized risk score, and then you can apply your whatever the cost of the solution to that perceived risk. And then therefore you can start to rank order the investments based on the benefit that you would realize from that potential investment. This can be done without having to do a very large, complex economic valuation of what those risks are. You can do this just in terms of number of customers impacted and potential duration, particularly for large events, because that's what you're trying to mitigate. And so that could really be a driver, and then any other factor you want to add into it as an attribute you could do without having to get into a complex economic analysis. So there's ways to get started on this. Obviously, you've got the tools to do the more sophisticated economic analysis. You could add it in as another factor, but that's what I would suggest. And so I would take a look at what California's done on their risk spend efficiency analysis, recognizing it's been adapted to wildfire, but you can adapt that to whatever aspects you think are important.
Okay. Do improvements that improve reliability always improve resilience? Is the reverse also true, that resilience improvements always improve reliability? And also, how do we value the added benefit that resilient solutions provide when reviewing these investments?
So it's important to understand what we're defining reliability and resilience to be, if what we're saying is an investment that would prevent an outage, and forget whether the label is reliability or resilience, that and whatever that investment is about prevention ties to then, what threat are you trying to avoid? By hardening a pole to resist a hurricane force wind may also help you avoid a car pole accident, taking down that pole. So, hardening that pole, having, let's say, a steel pole rather than a wood pole, may be able to accomplish both. We characterize a car pole accident as a reliability event, characterize a hurricane wind force taking down a pole as a resilience event. But I think that, yes, you can use some of the same prevention measures can address both. But I think you need to look specifically at what it is you're trying to avoid, and whether that, what you do for the reliability type, causes, which tend to be things like car pole accidents and basically things like squirrels getting into equipment and tree limbs getting into taking down power lines, particularly at the distribution. Those can also, have direct relationship to, the kinds of measures you would use or solutions are also beneficial for the what we're talking about in terms of, the kind of natural events that may occur.
Thank you. Going back to a little bit more of a detailed question from earlier, have you found any analysis or tools that help utilities or other entities prioritize investments in grid resilience?
So the bow tie analysis is I would say, a leading practice to start to identify both what the priorities are. It also, both in terms of prevention and then also mitigation, to the extent that, if they say you harden the pole, in most cases it survives, but in, let's say, the most extreme Category 5 hurricane, it still comes down. Now you're into mitigation, you're into your Plan B mode. So that methodology is a leading practice on how to think about investments that then also incorporates your threat assessments and your risks that are exposed. So you can go through that risk spend efficiency based on that approach. So you do your threat analysis, then you do this bow tie analysis as part of the bow tie. You're then also able to then incorporate and do a risk spend efficiency, which then allows you to do the prioritization. That kind of approach, I would say, is kind of the leading practice about how to think about this. And we do have several utilities across the U.S. employing this. The utilities in California do. I know the ones in New York have been doing it for some time post Sandy. I'm guessing there are others as well, but that's what I would look at.
All right, we have a little bit over 5 minutes. I'll try to get through 2 questions. So relatedly, the concept of potential impact of threats presumes the risk ranking is a subjective exercise. Are you familiar with any jurisdictions, perhaps Hawaii, that have any objective data to back up their risk ranking?
So Hawaii was more of a subjective process. It was kind of using a Delphi method where you had a lot of community and folks that are knowledgeable about the critical infrastructure. They're knowledgeable about, you had experts on the climate changes and impacts on the severity of the events that may occur. And so that was fed into a discussion, and as a result, they came up with those rankings. From that point, once you understand that, then you can start to think about, well, those threats and what's the impact. The impact on the system then becomes much more of a quantitative exercise, if you will, as opposed to just subjective. I think it really just depends on what's the history. I think with some of the hurricane, I'm guessing, because we're seeing these more patterns in terms of the severity and what the impact on the system, I think there's a better understanding. I know from the work I'm supporting right now in California on wildfires, it's much more moving towards a quantitative analysis because there's a history being developed. So if you have events that haven't really happened, like in Hawaii hasn't really had a hurricane in almost 20 something years, knock on wood. But there's not a lot of history. But in other parts of the country, obviously, we've been seeing repeated, pretty significant hurricanes and other storm, say in the upper Midwest, that you can start to look at some history there and start to do some more quantitative assessment of what the impact would be.
Thank you for that perspective.
Mm-hmm.
So one question that has come up is, how do we resolve the tension between the robust information sharing that some voices in the utility industry say is critical to this area and protecting information to preserve cyber and physical security?
Yeah, it's a real challenge. I don't have an immediate answer because the cloak of cybersecurity and national security has come over a lot of that infrastructure, starting with transmission and into key distribution substation level. I don't have an immediate answer, unfortunately. I think it's something that's going to have to get worked through. I got to believe that we, as has been the case in operations, that some folks can have a designation, because some of this isn't top secret, right? Some of this is just sort of classified level. I think understanding really what level of security is needed, and therefore what sort of agreements need to be put in place so that certain individuals can see this information and be able to assess it. I think my sense is that can be addressed. Because just knowing substation locations and transmission maps, that, by the way, used to be public information, but now have sort of gone under this cloak. I've got to believe you can have people access that under the right sort of agreements or constructs.
Great. We have 2 more minutes. I can give you another question, or if you have any final words, we'll take those too.
If there's another question, happy to entertain it.
Okay. Let's see. What role can distributed energy resources play in improving resilience of electricity systems?
Well, the distributed resources, I think, really twofold. One is how are those resources, energy producing resources, helping to satisfy backup power for customers? And what we've seen over the last couple of years, an explosion of the use of battery technology as an alternative for backup power, as opposed to some sort of diesel generator or gasoline portable generator or natural gas generator. So I think we've seen now, particularly residential, maybe small commercial, a lot more battery storage. In fact, Generac, the leading supplier of backup generation, stationary generation, added a battery division to their solution set here recently. So I think the trend is there. So that clearly comes into play. On the grid side, if we're talking about more of these community-based solutions, then I think we need to look at the role that community-based microgrids can play. And we have a couple of states that are actively pursuing these and looking at them. Certainly, there's the development in Illinois around the Bronzeville project, but we have in California, we have Hawaii, activities in New York and other states that have been pursuing tariff options around these, community-based or front-of-the-meter type microgrids. And I think that's an area to consider how that development may emerge. I have a paper with SEPA that I wrote with Jared Leader on community microgrid or multi-user microgrid tariff development based on the learnings out of these various states to date that's available.
Wonderful. And